So we're looking at this test here, which is the first half of the statistics course of Maths Apps. We're going to go through this question by question now and just have a look at how to answer each of the questions. The first one has a look at sampling size, and basically there's a high school, 840 students in that high school consisting of 430 males and 410 females. And this is the amount of students there are in each year level. So from year 8 got 140, year 9 164, and so on. The survey, basically they want to conduct a survey which looks at 35 people of this population, but what they want to know if that 35 people is an appropriate number of students. So what you need to do here is firstly use the formula to find out if this is an appropriate number of students, and the way you do that is the square root of the population plus 10% of the population. So the population in this case here is 840. So what you do is you just plug in 840 into the formula, which I've done here, and you get an answer of 112.98 students. Now, as you can see here, obviously as well, you would round this up to 113 students. And as you can see here, it's well over the survey of 35 students that they want to survey. So you can say that, no, this here is an appropriate number of students for this population, as the minimum should be 113 students. The next question has a look at random sampling. So they say if they conduct a random sample, is this method appropriate to get an accurate representation of the school? Well, no, not really. You know, a random sample can work, but at the same time, what's more than likely going to happen is that you're going to get more students from a particular year level than you would get from a spread of the years. As you can see here, there's 12, in year 12, we've got 248 students, compared to year 8 where we've only got 140. So there's over 100 more students in year 12 than there is in year 8. So we've got to have a few more students in year 12 conducting the survey than we do in year 8. Otherwise, we're not going to get an accurate representation of each of the year levels or the number of students from each year level. So a random sample, what could happen is that you get, say, by sheer luck, 90 students from year 8, and then you only get, say, 5 from each of the other year levels. Now, that's not very likely, but it could happen, and that's where bias could occur with random sampling. So what we need to do is the stratified sampling method, which shows the best representation of the population because it divides each of the population, divides each of the number of students for that year level into how many you need to survey. So the next question here does get us to look at a random sampling, at a stratified sampling method. So there was 410 females in the population, and out of the 840, so they want to know how many of the students we need to survey with the new sample. So the way we do that is we go 410, so that's the population of the females, over the entire population, which is 840, times 113, because that's the population, the minimum number of students we require for the survey. And you'll get an answer of 55.15 females. Now, in general here, what you would do is round up, but we can't round up in this situation here because if we're kind of splitting this into males and females, the males would require 57.85 students, which then you would round that up to 58, so meaning the females would have to round down to 55. The year 10, so this one here is breaking it down into year levels. So we know that there's 156 year 10s in the population, and there's also, again, from the population of 840. So what you need to do in this one here is break down the sample we've got of 156, so divide that by 840 to get a ratio, and then times that by the 113 minimum required, so you'll get 20.99. Now, what you want to do with this one here is round that up to 21, so you have 21 year 10 students must be surveyed to ensure an accurate representation of the data. They suggest having a look at 3 males and 3 females from each year level and discuss any bias that may be evident in that. Well, as I was saying before, we've got a lot more year 12s than we do any other year level, so we can't just do 3 from each year level because it's not going to accurately represent the year 12 population. So basically you need to make sure that you're doing a stratified sampling method to ensure you get the right number of students from each year level, appropriate to the number of students that there are in each year level. So we've got the next one now, which looks at chess wins over the past 2 years, so player 1 and player 2. This is the number of wins they've had, and basically they just want you to fill out a table here, so you just sub the numbers into the calculator and you should come out with a mean, a standard deviation, minimum, quarter 1, median, quarter 3, and maximum. So once you fill that table in, then what you want to do is have a look at the outliers. So you're looking at the lower fence first of player 1, and the lower fence here is, so remember you have to look at quarter 1 minus 1.5 times the IQR. And in this case here, the IQR is quarter 3 take quarter 1, which is 5.5, and quarter 1 is 6. So you just sub those numbers in and then you solve it. So the lower fence for player 1 was minus 2.25, which you can see that you can't have negative wins, so there's not going to be any outliers, over the lower fence here. The next one is you have a look at the upper fence, and that's quarter 3 plus 1.5 times the IQR. So again, the IQR is 5.5, that doesn't change, but the upper fence here is 11.5. So solve that and you get 19.75. Seeing as though you hit that, the player 1's max was 12, obviously you're not going to get a number higher than 12 for the upper fence, which requires 19.75. So again, there's no outliers for the first player. Looking at the second player now, so you've got subbing the numbers again to the formula. Again, you get a negative number, so there's no outliers on the lower fence here for the second player. However, in the upper fence, when you sub in the numbers, you'll see that you'll get an answer of 10.75. So you can see that the maximum that player 2 had was 12. So this one here is an outlier. You need to go back to the data and have a look at all the numbers over 10.75, and you'll see that there's only one here, which is the 12 there. So just have to have a look, make sure that all the numbers that are over that are actually outliers, and in this case here we've got one outlier. They want you to have a look at the recalculate the data again, minus the outlier. So we can see here that once we've recalculated getting rid of the maximum of 12, it just dropped the maximum way back down to 6, and the mean is dropped by almost 0.4, standard deviation is dropped by a bit more than 0.7, and quarter 3 has been affected too. The next part here is to draw a box plot without the outliers, and basically we've got to make sure there's a few things in this one here. You've got your title for the graph. You also make sure you've got a units for the table too, and basically just compare both box plots by using the 5-number summary here. So here we can see that player 1 has got a much bigger range than player 2. Player 2 is a lot more clustered together, whereas player 1 has got numbers from 0 to 12. So here the question gets you to look at the two players and which one's more consistent. So the way you look at which one's more consistent is you have a look at the range of the box plot. So you can see that player 1 has a range of 12, whereas player 2 has a range of 5. Also you can look at the IQR. So the second player has a range of the first player has a range of 5.5, whereas the second player only has a range of 3. So again, the IQR and the range shows that the closer the numbers are together, the more consistent the results, because they're not quite as spread out. And as well, you can look at the standard deviation in this sense, which helps us give a little bit of an idea. And the standard deviation is quite a bit smaller, almost twice as small as player 1. So consistency-wise, player 2's numbers weren't quite as spread out, so they're more clustered together, meaning that it's more of a consistent result. So this one here, looking at which of the two players is better. So you can do this one a number of ways. The way that I would say the best to do it is that remember each of these parts here represent 25% of the data. So there's 25% there, another 25% here, another 25% here, and another 25% here. And even though the player 2 was more consistent, player 1 showed that 75% of the data 75% of the data showed that player 1 scored 6 or more wins 75% of the time, whereas for player 2 that was a maximum when they got 6 wins. All the other data was below that. So which of the two players was better? Well, on average you would see that the first player would score more or less over 6 3/4 of the time. 6 wins. So you would say that the first player here was would probably be a better player. So looking at this data now as a stem and leaf plot. Now it was already working with single digits. It was a little bit hard to draw up a proper box plot, but what we have wasn't box plot, stem and leaf plot, but what we've done here is just have a look at the consistency, and basically you can see that this one is a lot closer together, so that's why the data recorded had a closer IQR range and standard deviation, whereas this one here you can see there's a binomial distribution here, so you've got two modes from 6 and 12. How would you describe the distribution of the two scores? Well, firstly, you would have a look at each of the sides. Now, this one here, we can see there's a binomial distribution, as I was saying before, because there's two modes. They got 12 wins 5 times, and they also got 6 wins 5 times. So there's a bit of a, two humps coming in this stem and leaf plot here. Whereas the first one, we can only see that there's, with player 2, there's only a there's a bit of a cluster through the middle here, but it's kind of deviating a little bit to a negatively skewed bit of data just because you have a bit of a drop off here. So this one here you would call more or less a negatively skewed distribution, whereas this one here you would call a binomial distribution. And the last question, what assumptions have we made above? Well, we've made quite a few assumptions that I guess firstly that the two players actually play in the same division. Another one could be that they are of the same age as well, playing the same age group. Could be that different format. Could be playing different days of the week, which could affect results. Different competition. So it's there's a few things that we're kind of assuming that is the case when comparing these two players here, because they haven't really given us the information for it. You can make a few arguments in this case here. So I hope that's helped out. Thanks very much.